Today we're going to look at momentum. We need to be able to define what we mean, recall its units, and confidently rearrange the equation too. It's always good to see what you can remember, so start by thinking about the equations for velocity, kinetic energy, and weight. When you're ready, press play to continue. Okay, let's review the answers. Give yourself a big tick if you've got velocity equals distance divided by time. Another tick if you have kinetic energy equals a half times mass times velocity squared. And finally, another tick if you have weight equals mass times gravitational field strength. So it's always good to review how you've done. If you've got 3 out of 3, great. But if you need to do a bit more work on one of the equations, spend a bit of time writing them out a number of times now before moving on. Okay, as I said, today's topic is momentum. So have a think, which one of these two animals, the bee or the elephant, is going to hurt you more? And when you're ready, press play to continue. Let's ignore that the bee has a sting. The bee does have a smaller mass and it has a lower velocity. So I would say if the bee hit you, it's going to hurt you less than the elephant. The elephant has a much larger mass and a higher velocity, so therefore it has a much higher momentum. If an elephant charges at you, it's going to do you far more damage than the bee. Just thinking about momentum in a different way, let's think about lorries. So why do lorries have a speed limit of about 60 miles per hour on UK motorways? One of the reasons is because of the large mass. And then it also means that if it's moving, it's going to have a large momentum. And a vehicle with a large momentum, or an object with a large momentum, is harder for it to stop. A bigger force needs to be applied. And you'll see more of that when you look at the conservation of momentum as the next topic. So let's go to the equation. Momentum equals mass times velocity. So mass is measured in kilograms, velocity is in meter per second. And finally, the unit for momentum is kilograms meter per second. As a study tip, you do need to remember this equation, momentum equals mass times velocity, and you'll also be expected to rearrange it as well. You'll need to know the units, so momentum, kilogram meters per second, mass, kilograms, velocity, meters per second. You may find it useful to remember the symbols. Momentum has a symbol P, velocity V, and mass M. So let's look at using a triangle to rearrange the equation. So let's pick out the key things, so momentum, mass, and velocity. So mass and velocity are multiplied, so they go next to each other on the bottom row of the triangle, and then momentum goes at the top. Let's think about those units, and now we can add them to our triangle as well. Notice we have kilograms and meters per second multiplied, so that's why the units for momentum are kilograms, meters per second. As I mentioned earlier, some people like to know the symbols P, M, and V, but I would say as another study tip, in exam questions you will never be asked for P, M, or V. They will always use the full words momentum, mass, and velocity. They'll never use shorthand. However, some people like to remember the symbols P, M, and V, and it would look like this. So now is a good time to start looking at some questions. So you've got 3 questions here, A, B, and C. When you're ready, press play to continue. Okay, let's go through the answers to question 1. First of all, let's write out the equation using our equation triangle, so momentum, mass, and velocity. So then we can write out momentum equals mass times velocity. We can see our mass from reading the question is 1150, and likewise the velocity is 50 meters per second. And then using a calculator, we get 57,500 from multiplying those two numbers together. Part B is the same skill, apart from this time we're changing our velocity. So 1150 times 72, which then gives 82,800 kilogram meter per second. For part C, we've got 35 meters per second now, and that gives an answer of 40,250 kilogram meters per second. From reading question 2, we need to rearrange the equation, but let's start again using our equation triangle. So momentum at the top, and then mass times velocity underneath. So we want to try and find the velocity. So velocity equals momentum divided by mass. We know the mass is 63. And for part A, we can see the momentum is 63 as well. So then we need to do 63 divided by 63, which of course is 1. But let's also remember to include the unit, so 1 meter per second. Then it's the same skill for part B. So we have 25.2 as the momentum divided by 63, and that then gives us a velocity of 0.4 meters per second. For part C, it's 472.5, and then divided by 63, and that works out to be 7.5 meters per second. In part 3, again, we need to use the equation to rearrange it. So we've got momentum, mass and velocity in our triangle as before. Let's highlight the key things that we need to know. So in order to calculate the person's mass, we need to know mass equals momentum divided by velocity. And we can put our numbers in. So we know that the momentum is 14.4 and our velocity is 0.6. And then by putting it into a calculator, we can calculate the person's mass as 24 kilograms. For part B, same skill, except this time the momentum is 44.4, and that works out as the mass is 74 kilograms. And finally, part C, it's 57.6 divided by 0.6, so the answer is 96 kilograms. And finally, let's just check our understanding. So here are 4 more questions. So when you're ready, press play to continue. So the units for momentum are kilogram meter per second. For mass, it's kilograms. And for velocity, it's meter per second. Give yourself a tick if you got those 3 correct. For question 2, we have a mass of 15, a velocity of 10, so mass times velocity, 10 times 15, gives us 150, and the units are kilogram meter per second. For question 2, we need to rearrange the equation. So mass equals momentum divided by velocity. And then we know that the momentum is 250 kilogram meter per second, and the velocity is 25. So 250 divided by 25, which then gives 10 kilograms. And finally, when would a suitcase have no momentum? Well, an object has no momentum when it's not moving. So the final one for question 4 is when it's stationary.